Before delving into the assertion, it's vital to first clarify the concept of molecular fuel pedals. The Large Hadron Collider, LHC, operated by CERN, stands as a 17-mile loop of superconducting magnets, and it holds the title of the most prominent and powerful atom smasher on the planet. This machine signifies the peak of human accomplishment, and in fact, it is so potent that it can recreate the conditions of the universe's first moments after its creation. But could the very machine built to unravel the cosmos's secrets unlock something more profound? Founded in 1954, CERN is one of the most renowned research institutions globally, with 23 member countries and countless researchers. It serves as a hub for collaboration and innovation. While the LHC is CERN's flagship project, it is just one facet of a vast network of fuel pedals and experiments. Imagine a path not for engines or people, but for subatomic particles caught in a trial of endurance and space itself. The LHC accelerates protons to nearly the speed of light, propelling them on a collision trajectory that mimics the energy present just after the Big Bang. These collisions generate temperatures far exceeding the sun's core, and a vast array of magnets directs the protons along their path, while sophisticated cooling systems maintain the magnets at temperatures colder than outer space. The beams within the LHC are designed to crash at 4 different spots along the collider's ring, meeting the particle detectors at 4 designated locations: Atlas, CMS, Alice, and LHCb, each with a specific purpose in exploring various aspects of particle physics. Together, these massive detectors act as monumental cameras, capturing images of these high-energy collisions. Scientists then analyze the resulting particles, searching for signs of the elusive Higgs boson, often referred to as the God particle, and other anomalies that might provide insight into the fundamental building blocks of the universe. By exploring the microcosm, we gain new understanding of the universe. Yet, with each answer, fresh questions arise, and with each discovery, new challenges present themselves. The LHC is not merely a scientific apparatus, it symbolizes humanity's enduring curiosity and progress. It reflects our unwavering mission to understand the driving forces that shape our universe. However, as we continue pushing the boundaries of knowledge, we must remain mindful of the deeper existential questions that inevitably surface. What are the risks of probing the unknown? Could our quest for knowledge inadvertently unleash forces beyond our control? Within the revered halls of CERN, where human understanding is constantly expanding, a revelation has emerged that sends chills even through the most experienced scientists. Brian Cox, a former CERN physicist and a leading voice in the field of particle physics, recently made a statement that left the world both fascinated and uneasy. Cox declared that the purpose of the LHC is to recreate a mini Big Bang. Yes, you heard it correctly, a small-scale version of the very event that gave birth to our universe. The physicist went on to discuss the profound implications of this goal, highlighting the LHC's potential to unlock mysteries such as the Higgs boson and dark matter, a mysterious substance that constitutes a large part of the universe. Imagine possessing the power to recreate the very forces of creation itself, the ability to summon the universe's essence. It's an alluring possibility, but one fraught with peril. The mini Big Bang is not just a theoretical concept, it's a real phenomenon that takes place within the LHC. The extreme temperatures, pressures, and raw energy involved simulate the conditions that existed at the universe's origin. It's akin to standing at the dawn of recorded history, witnessing the birth of existence. But such immense power carries with it great responsibility, and the question remains, what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anatoly Borsky faced a disaster that would forever alter his life. While working at the U-70 synchrotron at the Institute for High Energy Physics in Pino, Russia, a failure caused his head to accidentally pass through the direct path of a proton beam. The beam, with a force unimaginable, passed through his skull, entering at the back of his head and exiting through his nose. The experience was harrowing. He saw a flash brighter than 1,000 suns, but felt no immediate alarm. The beam's path left destruction in its wake, burning tissue and bone. Yet he remained conscious and even walked himself to the center for medical treatment. The aftermath was both troubling and surreal. The beam caused localized tissue damage, including hearing loss in one ear and partial facial paralysis, yet Borsky's cognitive functions remained intact, and he went on to continue his medical career. This incident serves as a stark reminder of the tremendous energy and potential risks posed by particle accelerators. The dangers of a particle accelerator like the LHC should not be underestimated. The possibility of catastrophic reactions or altering the very fabric of life are not mere science fiction, but real concerns expressed by respected scientists. One of the most disturbing and captivating issues tied to the LHC's experiments is the potential creation of a miniature black hole. Black holes are regions of space-time where gravity is so intense that not even light can escape. They are colossal vacuum cleaners, devouring stars and mysterious entities hiding in the shadows of the cosmos. The possibility that the LHC could create one, even on a minuscule scale, is awe-inspiring both to the public and to scientists. Could such a black hole grow, spiraling out of control and eventually consuming the Earth from within? Scientists have assured the public that any black hole created would be unstable and would vanish quickly. Still, this remote possibility has stirred debates, fears, and awe about the power we wield. To understand how the LHC could generate a black hole, we must first consider the basic mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy produced is so vast that it distorts the very fabric of space-time. Imagine a stretched-out trampoline with a heavy object dropped onto it. The fabric bends, and if the object is massive enough, it can create a well deep enough to pull anything nearby into it. This analogy illustrates what could occur within the LHC, inside the realm of quantum physics, where the laws of the universe can seem both strange and miraculous. There's a hypothesis that additional dimensions might exist within our reality. If these extra dimensions are real, the LHC's experiments could access them, generating a gravitational well that would form a small black hole. This peculiar dance of particles has captured the attention of many, including the late Stephen Hawking. In his writings, he warned of a scenario where the Higgs boson could become hazardous at extremely high energy levels, potentially leading to an event called vacuum decay. Such an event wouldn't just destroy Earth, but could conceivably obliterate the entire universe. Prominent English cosmologist and astrophysicist Sir Martin Rees also voiced concerns about CERN's experiments. In his book on the future possibilities for humanity, he explored the potential risks associated with particle accelerators, including those at CERN. Rees's warnings were not just cautious musings, They conveyed an undertone of existential dread. He outlined a worst-case scenario in which a failed experiment might cause a phase transition that would ripple through space-time, resulting in a disaster capable of engulfing the entire universe. While he assigned a low probability to such catastrophic outcomes, he maintained that even a slight risk warranted serious attention. Scientists at CERN have conducted simulations, analyzed theories, and taken numerous precautions to ensure the safety of the LHC. In fact, Brian Cox himself emphasized the importance of these safety measures, acknowledging the inevitable concerns and questions surrounding the LHC's operations. He reassured the public that stringent protocols are in place, with thorough reviews and procedures to ensure that the LHC's work is conducted with the utmost care. Cox also assured that the energies involved in the LHC's experiments are well within the levels naturally occurring on Earth, and that the likelihood of producing a stable black hole is astronomically low. Even if one were created, scientists claim it would dissipate quickly, releasing a burst of energy, a phenomenon known as Hawking radiation. Some have taken this idea even further, speculating that the LHC's experiments could open a doorway to another universe or dimension. While mainstream scientists largely dismiss this notion, it continues to captivate the imagination of many, fueling speculation and fear. Could we accidentally unleash forces or entities that we cannot comprehend? The idea of opening a door to hell has even been sensationalized in the media, amplifying the uncertainty. The notion of additional dimensions is not new to physics. String theory, a leading contender for a unified theory of everything, posits that there may be more than the conventional 3 dimensions of space and 1 of time. These hidden dimensions might be compactified or imperceptible, but in theory, they could be accessed or discovered under extreme conditions. Consider the LHC as a key that might unlock these long-forgotten doors. When protons collide at unprecedented energy levels, they could, in theory, create ripples or waves that probe these hidden dimensions. If such dimensions exist, the LHC may indeed uncover them. However, it's essential to approach this with caution. While the LHC is a powerful tool, there's no definitive evidence to suggest it will open a gateway to another universe, let alone to hell itself. The allure of the unknown, coupled with the mysterious nature of quantum physics, will continue to intrigue the public, but it's important to remain grounded in science. Should we be worried about the LHC's potential risks? It's easy to be swayed by sensational headlines and fears of global catastrophe, but the reality is that certain scientists are keenly aware of the inherent dangers. They've taken every precaution to ensure their experiments are safe, constantly monitoring and testing their work with great diligence. The potential rewards of the LHC's research, breakthroughs in understanding the universe, the discovery of new particles, and the exploration of dark matter are truly remarkable. The LHC is not only a testament to human ingenuity, but also a window into the very heart of the cosmos. But like any great scientific advancement, it comes with its risks, and we must approach it with a sense of wonder, respect, and caution. The LHC represents the frontier of scientific inquiry, where theoretical physics intersects with experimental reality. Its potential to answer fundamental questions about the universe, such as the origins of mass and the nature of dark matter, is immense. However, despite rigorous safety measures and extensive simulations, the LHC continues to inspire a sense of mystery and fear. The scale of the device and the energy it produces are awe-inspiring, and each new experiment brings us closer to uncharted scientific realms. While most scientists remain confident in the safety of the LHC's operations, there are fundamental uncertainties. What if new, unexpected anomalies arise that challenge our current understanding of physics and the laws of the universe? The LHC pushes the boundaries of human knowledge and tests the limits of our control over the natural world, raising existential